Okay, the last forecasting technique we'll talk about is in this video is associated forecasting, and it's just a variation of trend projection. Instead of having time periods and trying to forecast future time periods, in this case we simply have something that's correlated to something else. And what they've done here is they've given us an interesting set of data. This is actually from your textbook, problem 4.24 on page 147. The owners of a music store had this interesting idea that they wanted to see if there was a correlation between the number of times this band appears on TV and their drum sales. Apparently this band uses a lot of drums in their performances, and so their prediction is when there are more times on TV, then people come in and buy more drums. So it's not time periods, it's just the number of appearances on TV compared to their drum sales, and that's called associated forecasting. The trick to this is to keep straight which is your X's and your Y's. So which is the variable that you're plugging in that is using to predict the other variables. So this is your X in this case. So sometimes you have to read over the problem a couple times. One of the keys is later on in the homework they say, what if this were to happen, how much would this be? So that what if this were to happen is your X. So what is that independent variable that you're going to plug in to predict your X? And so we could do it the same way. Let's see if there's a relationship first of all. So I'm going to highlight the data. I'm going to go to Insert. I'm going to go to Chart, and then we'll hit Scatter Plot again. We don't need the lines, and we see that there is a relationship. So maybe not as well as some of the other relationships we've seen. It's a little bit more spread out. Once again, you'll want to double check that it did it correctly. One of the hints here is there's a 10. There's not a 10 in the number of drum sales. So we know that it's doing it correctly, that it's plotting the X's on the X-axis and the Y's on the Y-axis. For 10, there were 8 drum sales. So just double check to see that your chart is being done correctly. There's only one series. I always delete these off my graph just to give me a little bit more room. Of course, as we pointed out, when we are doing trend projections, you can do this a couple different ways. You can calculate the intercept yourself using the formula, so you don't have to use those complex formulas they give you in the textbook. So we're going to put in the known Y's, in this case drum sales, and comma, and then the number of times that they are on TV, and close parentheses. So there's our intercept, and then of course we can figure out our slope. It is a positive slope. We know that. Equals slope, parentheses, our Y's, again the drum sales, comma, and then our X's, the TV appearances. And so now we can put together this. We can predict our drum sales, our Y hat is equal to the is equal to the intercept. In this case, let's just simplify it, 1.329. We're going to add to that then the slope, 0.6585 times X, whatever the TV appearances are. And so there's our formula. Now we can plug in. And so that's what they ask us. They actually ask us, let's figure out for 9, if the band was on TV 9 times, what would be your forecast? So we can figure this out. We got the intercept here plus, and then the slope, 0.65 times our 9 appearances on TV, and that would tell us that we predict that 9 appearances on TV will sell about 8 drums, just over 7 drums. So you can do that. You can go back here, and like we showed you, if you plotted it, if you click on these things and do a right click, add the trend line, you'll see that it draws the line. It assumes that you want a linear regression, and then remember we talked about going to the options and displaying the equation, the r squared value, and so we have then those values here. You'll see once again they do it in reverse to what we have. The correct format is this way, and they give you R squared. So here the R squared is a little bit different. Remember, this is correlation squared, so we can interpret this 67% of the data. So, it's not like other ones that had a very high percentage, but 67% is not bad. It's greater than 50%. Oftentimes they'll have a cutoff of 70%. So there's some other reason why drums are selling at the pace they are. It's not just appearances, but appearances do account for about 67% of the data. You can see that there is some differences based on other reasons. The other thing I wanted to go back to the Y-intercept. We talked about the Y-intercept. Y-intercept can be interpreted as what is just the normal level of sales. If we don't look at time periods, we don't look at TV appearances of this band or any other variable, we can expect to sell, about a little over one drum set every single time in regards to our forecast. That's just kind of the minimal level of demand. So a lot can be interpreted by this thing. So the last thing that we need to talk about is seasonal adjustment, and that will be the last video in regards to Chapter 4. But this is associative forecasting, where you don't have the time periods which you renumber in sequential order. Here you have something that is correlated, in this case the TV appearances, to drum sales.